Right, and the ESR might not prove anything on these, you know, because they're so small. I was just measuring some of my other caps. 10s, for example, they measure like 8 or 9 ohms, brand new ones, never been used. Maybe it's because they were an eBay special, I don't know. So I think I need to get some more 10 microphones. But anyway, I figure just to bodge test this, I'm going to fit some Panasonic FR series. These are like 0.1 of an ohm. Yeah, they're a higher voltage, like 25 volts, but 0.1 of an ohm. Because I don't have anything else to test with. I just want to test this. Yeah, I want to test this theory. Because it might not be these. That's what I'm thinking. This one again measures the same as that other board, where it says in circuit leaky. And I don't think it's the cap. I actually think it's what is, you know, where it's situated. If you see what I mean. And the band on these is the ground. If it does work, obviously I'll swap them out with some SMDs when I get the parts in. But right now I just want to just bodge 2 caps in and retest it. I think this is a fruitless exercise. My view is the caps on these, whilst they may need replacing, aren't the actual issue. But the reason you wouldn't want to bodge something like this on there and leave it on there is the weight of the cap ultimately, you know, can damage the pads. I mean, on something like this it might be an issue. Certainly on a Game Gear, that's something I shy away from, sticking something like this on a Game Gear if I can avoid it. Although I have done it, because, well, beggars can't be choosers. Trying to find caps that are the right sort of size footprint for those Game Gears can be a challenge. I realise I'm slightly out of focus there. Getting a tiny bit of solder. So this one here was ground towards the, hang on, right, yeah, you can see the positive marking there, that's handy. I didn't notice that until now. That's that one on. That's that one on, just try and bend it carefully downwards a bit. There you go, that shouldn't protrude. So yeah, very tight on clearance, but they don't really sit up any higher than anything else here, so I think that'll be alright. Right, let me give that a try. I'm not even going to clean up because we're going to come back in here at some point to put proper caps on. Now we know the caps made no difference on the board that's in here. I'm going to take this optical unit out. We've got the one which tested OK here, marked it OK, that had a new spindle thing here, and the motor needed lubricating, didn't it? So we'll test this again, make sure this is still working. It's probably at this point now we find this one isn't working either. Right, that's that. And if this works, I'm going to start testing each of the logic boards on all the drives that do pretty much nothing, and ascertain the state of the logic boards and mark them all up. Because that's just going to, well, speed things up, isn't it? Divide and conquer. So let's switch it on and see what happens with that. Good sign. Speed it up. Hang on, the TV's not the right channel. Thanks, Sony. I'm going to do a mod to this TV, stop it from switching itself off. Yeah, that's loaded. So, power it off. I know you couldn't hear any sound there, it was sat on the memory card screen, but that works. So we'll start by testing this logic board, which is currently, you know, not fitted to anything, which I think has got some questionable caps. I want to see if it works. Now, there could be two things going on here. It could be that when the caps start to fail, the drive has a harder time, and eventually the drive, you know, the optical part of it fails as a result of bad caps. So, yeah, we may find it works with this other board. Would you want to leave it like that? No, you wouldn't. You'd probably want to recap it. So, yeah, this is going to be fiddly now, isn't it? Switch it on. That's working. So it goes to show the ESR really doesn't seem to make much difference. Yeah, and something I'll point out is put this screw here. If you're going to put one screw, put the one next to the connector, because when you lift it out, it separates. So the connector's still connected and the metal can comes up. So, yeah, that's something I just learnt there. You know what really bugs me about dealing with these? That the main issue It's not necessarily reconnecting things, it's doing this. It's winding the sled all the way down there every single time you want to do anything in here. Even just adjusting the pot, this is what you've got to do. You've got to wind the sled all the way down to the bottom so it's almost coming out the end of the drive. Why they didn't put the potentiometer in an easy to access place, I don't know. There are so many design questions I have about this. Hang on, I'm on my turn here now. Yeah, it just could have been so much easier to work on with a few simple tweaks. I'm going to mark this as okay. It needs a recap. You can tell, you know, it's not had any work on the capacitors there. Is there a suitable place to mark it? Red ink would have been better. Anyway, I'll mark them all similarly so we know that that's alright. Yeah, so this one is the one we bodge fitted caps and things in, so you know, replaced a few. So let's test this board next, but I'm fully expecting this one to work, because if the other one works and it didn't work in here, logic says yeah, it's not about, it was never about the board with this particular drive, it is the optical. And maybe the final test would be to test the lasers on that drive, but I need to make sure they're the same. Like this one's got a different thing on the underside here. If we look at this, I think, oh, I can't even see now. Yeah, look at the underside there, the pickup. It's like a little square IC, you know, rectangular IC. Look at the one there, completely different on that one. So these do vary in terms of which laser from which manufacturer goes with the main assembly. We covered that earlier, didn't we? There's a wider channel for the lens to move up and down on one of them versus the other, despite the fact they're all from VA1s. At least doing it this way, I'm getting to a fast conclusion of, well, it's all the lasers are all bad. If anything, it gives you an indication as well about the odds of lasers being bad. I mean, the fact we've got 12 of these here and only 2 or 3 of them are working at this stage, I think. That's going to damage my Dreamcast motherboard connector here. Right, let's power it on. Yeah, so that was the slightly recapped one. And it's working. Yeah, you can see that there. So I'll go and get another one out, take that out, mark that PCB up and test the next one. Anyway, I'll report back if there are any interesting discoveries. Yeah, so I discovered one that I'd not adjusted here. It was original 1043. I reduced it to 800 and then it works, and I thought, oh my god, it works. So I've increased it back to 950, so it's not far off where original was. Still works perfectly. So this one just needed a tweak, or it needed me to go inside it, I don't know which. But anyway, that one seems alright. So I'll add that to the pile of good ones. I think we're about 50-50 at the moment. I think 50% of them are going to need some work doing to the laser or the mech somewhere, and 50% just seem to work or need a slight tweak, that's all. The interesting thing is these vary wildly, which makes me, when you get one of these with a really high resistance, I think you've got a good laser that could be adjusted for quite some time. The reason being is that resistance being quite high means the voltage has been reduced, you know, more than say on a drive where that's at 700 ohms. And I found one of those that had never been changed from factory. It's around 700, which shows that it needed a fair bit of voltage to get going. This didn't. So now this is at 950. This is as good as my original laser in my Dreamcast that was set to 933. So I reckon that you'd get years out of that laser. The tolerance is probably like plus minus 20% or more. So you could get one that's like super bright and it needed to be set here, adjusted quite a bit from factory, but as it ages naturally, the curve, you know, the aging pattern of where it emits, you know, it just goes down, 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 and then ultimately it plummets. But perhaps only when you get down to, you know, you've adjusted it 2 or 3 times, but each time you adjust it, you know, a tiny, tiny adjustment, so just till it works. And yeah, I'm sure that'll be good for years. I'm going to let this go a little bit longer. I'll let it go 3 sections of the demo here on disc 2, and if it passes that, because that's like, it seeks around the disc a fair bit to do that, I'm convinced that'll probably be alright. Yeah, no issues there. That's the third section of the demo, you know, third part. Sweet. Well, that was a pleasant surprise. And I adjusted this one because this one hadn't been adjusted. I just marked up with a cross, that's all. So any that I find where I haven't written the resistance here shows that I haven't attempted to just tweak it to see, will it spring back to life? I may as well get the screws back in this now because, well, that unit is good. Yes, this next one could be a logic board fault, but I'm suspecting focus. Watch. This is spinning. Not focusing up and down. So yeah, it could be a laser, but it might actually be the drive logic for that. Yeah, it's got a torn/worn ribbon. Yeah, there's a mark here. I can't honestly tell whether that's a split. I think it is, you know. I think the issue with this one is the ribbon. So let's disconnect the ribbon and inspect it. There's no harm done. I can always reconnect it later if that isn't the case. So I'm just going to use the tweezers here to try and pull like that. It's a split. Yeah, you can see it more clearly there. I'll put you on the microscope in a minute, but that ribbon is borked, so there we go. This drive might work as well. That's going to be good if it is. Right, it's connected up. I haven't adjusted the thing because we had no focus originally. There's no point in trying to adjust the laser if it's not bobbing up and down. Let's just see if it's bobbing up and down now. Yay, it's bobbing up and down. There's a chance this may work without any calibration. Oh yes, another one lives. Bad ribbon. Right, I'm just going to put my screwdriver there. That's it. Let that go around the demo, all 3 sections, and I'll report back. I like it when they don't need adjustment because, well, it's almost pretty much good as new, isn't it? When it's not good as new, it's been used for God knows how many hours. So let's have a look at this corroded one next. There's some corrosion up here. I wrote on it, focus corrosion. So maybe this one's like the other one. Hang on. There's no ribbon. There's no ribbon. The ribbon's not connected. No wonder it's got no focus. The ribbon's not connected. That's interesting. And this has never been unscrewed. Well, that explains this one, doesn't it? I bet this one works. Right, I haven't got that shield off. The board looks alright. Caps look alright. Maybe it is just some localised corrosion just down here. So anyway, I'm going to try and clean the PCB up. But the ribbon is definitely not connected to the actual laser. Yeah, switch contacts seem alright, and they go through, so even on the top side here, it's not really an issue. But what I will do is just get some contact cleaner in there. And I did this with a few of these, just to rule out there was some issue with that switch. You know, the ones where there was no focus, or it wasn't doing anything at all, etc. earlier. But I think we're at the stage now where everything is, each of these is doing something. There we go. So that's that clean. The ribbon is in there. I'll just give it one quick inspection to make sure I don't see any tears or anything. We've just got a crease up here, and I think that's happened at the point where, I'm going to try and just crease it back a little bit. I think that's happened when something's got jammed or something and it's pulled the ribbon out. I use the fiberglass pencil here, and yeah, we'll just clean each of these little bits of rust off it. Zinc plated, so you really wouldn't kind of expect rust there, but it has a way, doesn't it, of getting past the zinc. just because, well, there's a wee bit that's not coming off on each of these positions here. Right, just going to have a wipe over that with some IPA just to see how it's looking really. Yeah, all the readiness has gone from there. Yeah, most of it's gone from there. There's just a few little bits on the edge here, and obviously we've got that mount to do. But can you see this here now? That looks nice and clean, and around here looks pretty clean, and again all those little bits of rust have gone. Spindle looks okay, I don't see any splits in it. Feels like that's pressed down really low on this one. Maybe it has been pressed down, I don't know, I can just try it. Oh. Gonna end up damaging my disc, aren't I? Yeah, it feels like it's quite low, that. Yeah, what I'm going to do here is not stick my finger on the fuse. I keep doing that, I keep reaching over here for the power. It's going to get me that at some point, isn't it? Might be the last thing I do on my channel. You may never see the result. I could be talking to no one right now because this video might not air. Yeah, I'm just going to just adjust the voltage anyway. Now that we know the ribbon is connected. It clearly wasn't previously. Right, so that one works as well actually. I took the plastic top off, you know, the two screws that hold the black plastic piece, and I got my two prizing tools like this on either side under the spindle, lifted it off because it did look a bit low. Clipped it back on and it stands up about an extra half a millimetre, and it just sprang to life. Now that was after I tried adjusting the laser, and it came to life from just adjusting the laser, and I marked it there 583, that's what it was originally. I've set it back to 583 because I lowered it all the way down to about 450 when it first started working, but after adjusting the spindle I've been able to put it back to 583. No one's been in it, so its original resistance was 583. And in fact, when I set it back it was like 590 or something. I could try going higher and see if it still works. In fact, let's do that. Let's switch it off because it will just extend its life. I don't think anyone's been in it because the screws that hold the PCB have never been adjusted. Having said that, you can adjust it without that, can't you? You know, you don't need to remove the screws from the base. So someone may have been in it, then maybe that was why this was disconnected, because someone had tried to adjust it previously. Yeah, you cannot see the meter. I just adjusted that counterclockwise quite far. I'm now just going to see where we're at. And it's quite difficult trying to get onto those two contacts on the ribbon. Yeah, there's me saying it was easy to read from the ribbon, the first two connections, rather than the potentiometer, and it is, but it's even hard still trying to get onto the ribbon, if I'm honest. All you need is a bit of oxidisation on the tip of your probe and you can't measure anything. Yeah, 1090. That is well far out, so I'm going to start at 1090. I'm going to deal with these in a minute. I'm going to put a cable tie on because these wires continuously cheese me off trying to get them routed back into that channel there. Let's just see if it'll read when it's set to a K. I mean, if it does, it's a really good laser. But, well, I suspect that's not going to read now, to be honest. It's not sitting very flat, is it? Oh my god, it's reading. There you go. Someone had been adjusting it, I think, because that's now set to only all the way up to a K. Yeah, down from the 583. And an original disc is working. So that one's got a really good laser, I think. I mean, it could be from factory that was miscalibrated. This is the thing, you know, at factory someone was just set, you know, all you've got to do is get the RF level between one voltage and another. Some people got it near the middle, some people got it slightly near the bottom, some people got it right at the top. And that potentiometer has a direct relationship. So you know what, that laser is a really good laser. The fact it's working at K very pleased. So I'll deal with those wires, I think, and label that one up as well. That's another good one. I do need to think about that spindle height as well, because, you know, I clipped it back on. From factory, they had like a little bit of epoxy or something there, just trying to hold it at the right height. There probably is something there, but I'm not sure how I can secure that in a way that, because it's probably already still got the epoxy in the gap, if you see what I mean. I mean, I can look at it while it's spinning. Yeah, I can see some epoxy in it. Anyway, I'll let this go around the demo, all three, just like I did with the other ones. If it loads all three parts here, then I think we're done with it. That's interesting. When I started playing this, I've come across that bookcase and it says look like someone moved it. I don't know how you move it. I need to reinvestigate that. Maybe I forgot what the key combination is to push and pull things. Yeah, and this one works okay. This is one I adjusted earlier. So this is one that I noticed that if you've got bad connections here, it fails to read, but you clean it up and it's alright. So that may need recapping on the PCB. That's probably the issue with this one. But it was 1092 and I adjusted it down to 922, I think. And yeah, good as new. So the laser was a bit worn on that one, but we've not had to go down very much. The time to be concerned on these, I would say, is when you get below sort of 800 ohms. As soon as you get below 800 ohms, you're having to put a fair bit of power into it. Yeah, and another one is working as well. So again, I adjusted the spindle height, wasn't getting anywhere. Reduced the laser. Hang on, is it loading? It sounds noisy. I think this is the one I fixed the gear on before, which is why it sounds a wee bit noisy. And on the gear, I just used the grinding pen to get little bits of edges of plastic off the edge. So this needs some lubrication, I think, because it sounds pretty noisy. But it is working. That's like 8 so far. I've got 8 working. Yeah, and I think the gear on this one is going to need swapping out from the donor one. You know, it's had bits off, everything taken off it, hasn't it? Because it's really noisy, and I think it's that issue with the gear is making it slightly inaccurate in alignment. I'll give it one more test here on the 3 demo things on Veronica, see if it works. But it's froze on the 2nd or 3rd one before. It was like you could hear it reading, trying to read a bit. And I actually think the track alignment's not right because of that gear. Just listen to it now, we'll just see if we can hear it when it loads the next demo bit, because it sounds really grindy. I put Molycoat on there a minute ago, on the bar and on the gears and things. That made it a little bit quieter, but it's quite noisy when it seeks. That was quiet. A bit noisy there. Noisy there. That's working. Yeah, very dark, this scene. I mean actually visually, not like disturbingly. Anyway, I'll report back. Yeah, and this one has given us a ribbon, it's given us the top thing there. I tested the PCB on this one, it was alright. Up. Try not to lose that screw. Where's that gone now? Lift the motor out. Hang on. I'll try and slide that off. There we go. And I need to do the same thing on this one. Undo the motor. So pull the motor out, pull the gear off. It's stuck on there pretty well, to be fair. I think this is a good idea just to rule that out. Yeah, and then need to get the screw back in. Fed up with so many bits everywhere. See how noisy that sounds? Well, it's working, but it just sounds really noisy. Wow. I think that's slipping, you know. Well, there's irony for you. Oh, I've dropped it on the floor now. That one was split as well. It's not actually about that, I don't think. I'm going to take advantage, now this is off, I'm going to use the grinding pen under the microscope and just try and perfect it. You'll see what I mean. It's these bits on the edge here, I think. Oh, hang on, that's grease. Maybe I'm imagining things here. I don't know. So I finished looking at that other one, it's fine. This one is the one that reads audio discs but fails to boot Dreamcast discs. Now, speaking to Electrash about this one in particular, and he was saying he thinks it's to do with the error correction, like reading an audio CD is far easier than reading the high density area on the disc. Yeah, it just throws me back. It shows the Sega logo and throws me back, but the fact it reads the Sega logo makes me think it's identified it as a Dreamcast disc. So, could be a logic fault on this one. It's taking a while to spin up there, look. And then we get this. Does that not mean it's done the protection check? Anyway, so this one, I actually think I'm going to start, because I probably would have adjusted, yeah, I've written on it was 933 ohms. I'm going to start by swapping the PCB over on this one. Right, so testing the PCB from that drive in the one with a good optical here. We know that works, we've proven that. Let's put the disc in. Just see if it's still the same or if it's any different. Hang on a minute, it's not even doing anything now. That's interesting. You saw that? I had to spin that myself. Why did I have to spin that myself? Right, so it's got the Sega bit. And it's booting. So the drive PCB is okay. I'm not discounting that the motors on one or two of these need some contact cleaner in there and time to spin up and be used. That might be why I had to spin that there. Maybe there was some issue, I don't know. Yeah, but it's not doing what that other one was doing, which was giving us a problem with Dreamcast discs, but not, say, you know, CD audio. Now, looking at its ribbon's pretty well mangled here. You know, just looking at that, there are quite a few sort of creases around it. I'm just going to put it onto a flat surface here and just give it a bit of a massage with a cotton bud to see if I can massage any of the creases out. I don't see any tears, to be honest, so, you know, I don't think the ribbon's the issue. Right, I saved you the trauma of that. I originally took the motor out this side. It doesn't come out that side, it comes out the other side. I didn't break this. Managed to get it back in. Wires through this little hole here. There are bits of glue all around. Best advice I can give you is wedge a piece of metal like this and go like that, and it goes crack, crack, just gently around to split the glue. You can see it here. It's like a hard sort of epoxy sort of thing. Anyway, that's that off. Obviously you need to untwist the wire from there because it's twisted around that one like that. I'm going to retwist those back together just because, well, I'd like them to try and stay next to each other maybe. Anyway, that's it. And obviously the wire routes sort of in down here. There's a little channel thing there, plastic clip. So I could just pull those sort of back into position there maybe. So let me get that back into the drive and we'll give it a try. Right, so 8 out of 12 are working okay. We've got one that's pretty much balked because so many parts of it are broken now. It's just being used to fix the others. I've got 3 ribbons I'm going to test here. The logic PCBs we know are okay, but none of them work really. This one here, there's a good opportunity to show you. This is the pickup, yeah? It's detached, and it's just held with glue, and the glue seems to have given way on the underside as far as I can see. I can't even tell how that was glued on, to be honest. But anyway, it just sits over there like that, and I'll hold this up to the light in a minute, but there's a little hole there, and there's a mirror or something. Hang on, in fact there isn't. This one just goes straight through. Goes straight through to the lens. But the bottom line is, when I look through there, it kind of looks like yellowy. So there could be some contamination up there. This could be dirty. So anyway, I'm going to put all 4 of those into the ultrasonic cleaner and give it a bit of an ultrasonic. It could damage the cores, but to be honest, I have exhausted all options testing these. I cannot get any of those 4 to read more than, where it starts to detect a disc and you go like the focus going all over the place trying to get a lock on something. That's about the best I could get from one, and the other one just tiny little bit where it detected a disc but not much else. And that was the one actually that was playing audio, and it does still work, that one. Plays audio CDs, doesn't do anything else, which is weird, isn't it? I would have thought that was like a drive thing, but clearly it's capable of fairly clearly focusing on the disc, but not enough to read data. It can read audio, not enough quality of data. So anyway, I'll report back when those have had, I don't know, 5 minutes of the ultrasonic. Right, we're back from the ultrasonic. Yeah, so I mean, that may have adversely affected them. I've got nothing to lose, because I'm darn sure the issue is with these. Except for one of the assemblies where everything's balked on it. We've taken ribbons off it, gears, all sorts of things. So trying with some hot air, full airflow, 146 degrees. Right, good ribbon, good logic board. I've got a laser back in there. Just for the moment I've got the top off here, just in case the spindle needs any kind of tweak. So let's see if this is, and it's set to about 770 ohms, I think, the resistor. See if it does anything. Nope. This is the thing with these ones, they're not, there's just literally no life at all. I mean, I've got into quite a fast, hang on, where's my tool gone there? Fast routine now. You can just, like these ones anyway, the junky ones, lift them up, slide the assembly upwards like this. Yeah, you risk damaging gears, but I've done it enough times on these to realise you can sort of get away with it. Hold it like that, a bit of pressure there, get on the pot, go clockwise. In fact, on these ones I think you go anti-clockwise, I don't know. One of them you go clockwise, one of them you go anti-clockwise, which is a bit odd. Right, so we've got 2 each of these types of laser here, and the first one here, no red emission on the phone, so it's like that's the diode, it's not emitting, yeah. I think this is maybe the pickup, but the pickup may be the other thing here. I may try and swap them around between these 2 units. So yeah, that's a first for me. Because this one is doing the opposite. It's like we get the red thing here. Let me just double check that. If I switch this on, we should see the... Hang on. Yeah, I can see the red beam there. So, it's emitting, it's not picking up. So I think we've got the inverse on these. This is why I think if we swap these parts around, then I'll make a note saying that this one has the, emission, yeah, this one doesn't. And if you swap them around, the parts on them, I'm thinking the 3-pin device might be the easiest one to do this, because I could desolder the flex there, crack the glue, take it out, swap them around, solder them back in, and see what happens. And we may get one of them working. Whichever one then is emitting, I'll have an understanding of, was it this part that's doing the emitting, do you see what I mean, and which part's doing the pickup. But I think it'll be a valid test anyway. You never know, we might get one of them working that way. So that, I think, is the issue with that pair there. So let's take this out. I'm going to leave this chassis on this board, I think. I'll test another one of the ribbons. I'll put these to the side and get another chassis with another ribbon and test these two, because those two are the same as well. But I need to go find a chassis now that will work with those. Hopefully I've got one. Right, so I just beat tested this ribbon out, got one of the other two lasers onto this assembly here. It did take me 10 minutes off camera there. So let's do the first test here, power it on, see if the carriage moves and see if we get the red laser. Yeah, see the laser, that's good. Let's get a disc in. Fully expecting it's not going to do anything, but I don't know, let's just try. Yep, nothing. The adjustment we're needing to do for the laser is because the pickup part is not working, it's not as sensitive as it was. That's what I actually think is going on with these. Nothing. Yeah, so with these four, pretty much exhausted all options now. This one sort of has a tiny bit of life when the laser is like super bright. It shouldn't need to be that bright. I don't think the laser's the actual issue, I think it's the pickup. So I'll just check these caps here, hang on. Yeah, and just making sure we don't have a short. Yeah, they seem to measure about the same. It's probably just on coil or supply rail or something. I'm going to reflow this. I think this is the pickup. Technically we could try and swap these around on the two drives as well. I mean, it may not survive some heat in here. I'm not even sure if getting flux on it's a good idea, to be honest, but we need to. I'm just going to reflow it. We've got nothing to lose here. Because, well, it's doing very little. And I think the laser is the 3-pin device. But it also strikes me that I may even be able to swap parts from other lasers. I mean, well, not necessarily this part, because you've got to get the pin out right. You need to know what it is. And I actually don't know what it is. But like the 3-pin device, if you get the pin out right, maybe just by doing some experimentation and measuring where the supply rails go to it. I'll try and show you what I mean. This thing here. You've got 3 pins there. If you could work out how to power that, because I suspect that this is the diode, you know. I mean, why it's got 3 connections, I don't know. That's an interesting one, isn't it? And you can see it's glued in, but in theory you could unscrew it, you know, crack off the glue, swap this out. Maybe from a completely different CD unit. Right, so only one of those units is showing any signs of activity. And the resistor was set to 300 to 400 ohms before it would even do anything. So I think, in the names of, well, education, I'm going to do a few things. First of all, let's just see if we can get this cover off here. And have a look at that. So, yeah, there's like a plastic cover that looks like it's clipped on. I'm not sure if it's held down with that screw. It's glued on down there, though, look, I think. Or maybe it's not. Let's just see if this will come up at all. I'm just curious to see what's inside. Can we see anything? This is the one that's got a cross on it. It's doing nothing. Not sure what's holding it on here. It could be glued, there could be something stuck on it, we could damage this irreparably, but you know what, it's beyond, isn't it? So let's just see. No, it clips off that, I think. Famous last words. Like, what's that there? There we go. Right, that's that off. So, what can we learn about that? Well, not a lot. It's weird, isn't it? Ah, you can see the coils now. Yeah, you can see these neodymium magnets here, I think, aren't they? And the little coils. So these are the things that move this whole mechanism around. Well, it's interesting we can actually see in there. Obviously I'm getting the focus out slightly. So you must have, I don't know, like a north-south, because look at these, they're different, aren't they? All the different types of magnets, I don't know. You can see where the flex ribbon comes in, loops around. This whole thing moves like that, look. That's quite cool. So by applying low voltages, current controlled, so the inputs here, you could probably go, can it move that way? Can it move that way? What else could you do? And can it move up and down, I think? Yeah, this whole thing, raises up and down as well. It's quite clever, really, isn't it? When you look at how few things there are. There might be another coil underneath. There might be another magnet under there to make it go up and down. That might be how that works. Yeah, so we can't really, learn anything else from looking in there. You can see the lens is glued on, epoxied on. So if there was a problem with the lens, you could replace that maybe. I'm just trying to see more clearly. Like, is there a problem with this? Is this the issue? Is there some contamination in there? I don't know. You see this little white ring in the middle is the actual the ring light on the camera, I think. If I turn that down, there you go. So I don't know, it looks alright, doesn't it? Yeah, so anyway, coming back to that little 3-pin device, because that's there's some stuff here to check out. I've measured that cap, seems alright. The resistor is alright, but, and the solder points here. If I just get some focus on those, they don't look so clever, do they? Yeah, it's just an optical illusion. You could, of course, just try pressing these, and I'm sure I've done this already on these. Just check the solder points to make sure they're all good. Yeah, and our little trim resistor there. But what I was looking at is potentially swapping that, but that's quite hard. You'd probably, I don't know what you'd have to do, you'd probably have to replace all of this stuff here because it's on that same flex ribbon. But you may be able to prise this up and replace the actual component on the underside on this one. But the thing I was going to try and do here now is if I just put this down a little bit, hang on. I'm going to try and solder the 3 points here. Note, you've got to get it the right way up because, well, you've got 3 points. If you got this wrong way around, you could, it's not going to work, is it? It's glued though. It's glued into this little cavity. But I figure if we could desolder it, get the flat flex off the top of it, and then I'm going to try and prise it out and swap it with the other one, because this is the one that I marked. Oh, I've removed it now, the plastic cover. On the plastic cover there's a cross. This is not emitting any red light at all. You see, it's wanting to fall over is the problem here. Look, I can't do it. I think what we should do is just get some flux onto it. Right, just forced out some flux there. I mean, I have nothing to lose doing this. It's at the end of the line, really. So let's just see if we can. Oh, for God's sake! I need to try and hold it at the same time as use the thing there. Hang on, helping hand. You can see that removed a lot of solder there. That worked quite well. Because it's a flat flex, so it's like you want to heat this the shortest time possible, really. I don't know what temperature these things can sustain, but I mean, we've pretty much got most of the solder off. There's just a bit still on, maybe on each of those. Certainly this one down here. And I guess it's a question of, have we removed enough to free it up? I bet that'll probably come out now if we can free up its glue. I don't know, there still looks to be a bit there to me on that one. I think this flex ribbon's going to die doing this, you know. That one there I'm not sure about. Oh, it's moving around. Yeah, I'm not sure if that's up free. Don't know. And then, is this flex ribbon glued down, or how is this? How thick is it? Is it going to just lift up? Is it going to break? Maybe it is, I don't know. I could try getting an under here. There we go. Has that survived? I think it has. Yeah, so, yeah, this is the question now. Can we even get that out? I don't know. It looks like it's certainly stuck in. Testing again on stern wind. I've been playing this for a good 20 minutes here. Last bit, the planet explodes in the background. It's quite incredible. Or sun explodes or whatever it is. Star, isn't it, I think? Oh. It's the only weapon I've got left. I'm going to challenge taking this boss down with that. Yeah, so I do hope you found that interesting. I've tried to cover different things within the different videos in this series here. There's some different stuff in the next part, but actually the next Dreamcast video is going to be a repair video on my Dreamcast. The power supply went kaput in the middle of doing all this stuff. So yeah, the next part won't be the GD-ROM stuff, it'll be the PSU and looking at Dream Shell and just testing a few games out and stuff once we've got the power supply fixed. And then we'll return for what might be the last part, I think, for the drives there. But at the end of this part here, we've got 4 drives that have got problems, obviously. One of them was mostly used for PARs, but you'd be quite surprised by the end of this we get to the point where all 12 drives actually work, even though we borrowed PARs. Yeah, anyway, you'll see in the next part. If you'd like to support the channel, please see the Ko-fi and Patreon links down below. Thanks to Palm for pointing me towards these drives when they were for sale. I'll catch you in the next video.